Hello, I'm Craig Otto. This is Statistics for SPC and Operational Excellence. Today we're going to talk about the normal distribution. This is actually part one. There will be 7 parts here. First of all, we need to know what is the normal distribution, and many of us has probably seen this but never realized what it was. This is called the normal curve or normal distribution. We have some things that kind of make it that. There's characteristics, things that are important, assumptions that are made about the normal distribution. And the first is that it's bell-shaped with the highest point over the mean. In this case, in this example, our mean is 0. It's symmetrical about that vertical axis through 0. So this side is equal to that side. And as the curve approaches the horizontal axis right here, it looks like it kind of goes away, but it doesn't. It just gets so small you can't see it, but it never touches or crosses that horizontal axis. So just something to note. The transition points between the cupping upward and downward is at the 1 sigma. So right here it cups downward, and then from here it starts cupping upward. Same with on the other side, you have downward, then it starts at 1 sigma, starts cupping upward. And then again, for the standard normal curve, keep in mind this is something special. Standard normal curve, what's special about that is the mean is 0 and the standard deviation is 1. We'll use a lot of things with the standard normal curve. Okay, and the other thing to note about this is that 50% of your data on a normal curve falls to the left and 50% falls to the right. Okay. Other things that, because it's symmetrical and because of all the things that I was telling you about with the way it cups, there's certain things we can tell about it in terms of probability. So as I mentioned, 50-50 on each side of the mean, but also between plus or minus 3 sigma, 99.73% of your data, or 99.73 probability of the data falling between -3 and +3. -2 to +2 is 95.44%, and from -1 to 1 is 68.27%. Okay, very important. Other information that you can kind of decipher, because it's symmetrical, you can break these in half. So if you want to know between -1 and 0, it's 34%. Between 0 and -2 is 47. All this is this number divided by 2 because it's symmetrical. And same way down here, from 0 to -3 is 49.865. And continuing to break those things down, or informational things, from -2 to -1 is 13%. From -2 to -3 is 2, and from -3 to -infinity is 0.135%. So you can see, and it's symmetrical, so it's the same ones on this side. All of this is important. Mainly, when we use this in an application, if I'm mapping a process that's going along and it's going up and down, but then I get one that jumps out, that goes beyond that 3 sigma, that tells me something has changed. And it's not probable. Something is different. So that's why it's very important that we use this. This is what statistical process control is really all about. This is statistical process control. And you can see how the data, as I mentioned, 68% should fall between 1 and -1. If it doesn't, then you know something's different. So in this case, we had 8 out of 12 or 66, pretty close to 68. 3 out of 12 that fell between -2 and -1, which that should have been close to, if we look back using our chart, from -2 to -1, 13% above and 13% below was about 26% altogether. So we had, in our case, 25. So that's pretty close. But now, this 1 out of 12, when it fell outside of this range, the probability of that is 0.135, and this is showing 9%. So that's a big difference. That's why it signals something wrong with that particular point. Maybe the machine went bad, or maybe it's a good thing. Maybe your product went more into specification. But the main thing it signals is something has changed. It could be good change, it could be bad change. So knowing this, now we can start asking all types of probability questions. So what's the probability of getting less than 0? It's 50%, because 0 is your mean, standard deviation is 1. What's the probability of getting data to fall between -1 and 1? Well, you just got to use the chart. You got to use this chart back here. I'm jumping around, but you got to use this chart. From -1 to 1 is 68%. And the same thing with all of these. So keep this chart in mind, and as we ask the questions, -2 to 2 is 95%. From -3 to 3 is 99.73. And then the probability of data being less than 2. So when I say less than 2, you have to recognize that negative infinity to 2. So we're going from the left half of the curve, which is 50% of your data, all the way over to +2. So that's 47%. You add those two together, so 97% is represented from 2 or less on that normal curve. Okay. Now, you won't always have a mean of 0, obviously, and you won't always have a standard deviation of 1. So I tried to make the numbers, simple. A mean of 10 and a sigma of 2. What that will do, is what's the probability of getting less than 10? Well, 10 is your mean, so if it's less than 10, that's 50% of your data. What's the probability of it falling between 8 and 12? Basically what that is plus or minus 1 sigma. And the reason I know that is my mean is 10 plus 2 is 12. Well, that's plus 1 sigma. And if I subtract 1 sigma, 10 minus 2 is actually 8. So what I'm asking is, I say between 8 and 12, but on a standard normal curve, I'm asking between plus 1 sigma and minus 1 sigma. Well, it's 68%. Same thing here with 6 and 14. If I take 2 standard deviations times 2, because I'm 2 sigma away, that is 4. So 10 minus 4 is 6. And 10 plus 4 is 14. So it's plus or minus 2 sigma. So when I go on my chart and look at plus 2 to minus 2, it's 95% of your data. And then what's the probability of the data falling between 4 and 16? That is looking at plus 3 sigma and minus 3 sigma. How do I know? Well, it's just 3 times your standard deviation of 2 is 6. So 10 minus 6 is your 4. And 10 plus your 6 is your 16. So I know that between plus or minus 3 standard deviations, I have 99.73% of my data. So that's the probability. And then what's the probability of the data falling between 6 and 12? Well, I know that 6 is actually 2 sigma, negative 2 sigma, and I know 12 is plus 1 sigma. So I just take the probability of plus 1 sigma to the center is 34%, and from negative 2 to the center is 47%. Add those two together, and it's 81.855%. Alright, next time we'll continue on with more discussion on the normal distribution.